This is chapter 6, problem 29. The lucky number for this problem is 3. This chapter, we talk about a few things. Work that is equal to, oh my God, my pen is running out of ink. Work is equal to, mechanical energy is equal to force times distance. We also talk about potential energy due to gravity, that is equal to mgh. We talked about kinetic energy, that is equal to half mv squared. And we also talked about potential energy of a spring, that is equal to half times k times delta x squared, where k is the spring constant. Well, this is just a review of going all over the important formulas for this chapter so far. You should have written this somewhere in your notebook. Okay, so now we talk about potential energy due to gravity. Okay, so at the beginning over here, this the hiker is at 1270 meter. That's where he's at. Okay, and now he moves to 2660. So that's a new height. Okay, so what is the change in potential energy? So you look at the formulas. Potential energy due to gravity, is this the one? No, this is for spring. Is this the one? Yes. Okay, so it's equal to m. So potential energy due to gravity is equal to m. That's the mass. Times g, that's 9.8, times h is from here to here, or the delta h, that is 2660 minus 1270. Okay, so I'm going to punch in my calculator. Okay, it's 66.5 times 9.8 times parentheses 2660 minus 1270. Okay, so I get a big number. I'm going to give you in kilojoules is 906, equal to 906 kilojoule. Okay, what is the minimum work required for the hiker? Okay, so it's kind of conservation of energy. The work need to bring the person from here to here is against gravity, so the magnitude of the work should be the same. Potential energy is equal to 906 kilojoule. That means the work in order to bring the hiker up there is about the same. Can the actual work done by greater than this? Well, if everything is very ideal, that means you don't waste the energy anywhere. That means, yes, maximum work or minimum work, it should come up over here. And by the way, this is called a state function. That means energy is a state function. It only depends on the initial state and the final state. The lucky number for this problem is 3.